Yes, I welcome you all to the second session of the chapter on arithmetic progression. Let me first recall what we had learned in the first session on the chapter of arithmetic progression. I started with the definition of a sequence. As I told you, a sequence is a set of numbers arranged according to a given rule. The following sequences that are displayed on the board, the first one is a sequence of it's a sequence of perfect square numbers. It's an infinite sequence. The second sequence is an arithmetic progression. You can see I have taken the dates of all the Mondays of the month March 2021. 1, 8, 15, 22 and 29. 1, 8, 15, 22 and 29. The sequence over here is a finite sequence, and this particular sequence is an arithmetic sequence or an arithmetic progression because the difference between any two consecutive terms is a constant. If I see what is 29 minus 22, 29 minus 22 is 7, 22 minus 15 is 7, 15 minus 8 is 7, and 8 minus 1 is also 7. The first sequence that is on the board is an infinite sequence of perfect square numbers. The second one is a finite sequence. A sequence having a finite number of terms is called a finite sequence. A sequence with infinite number of terms is called an infinite sequence. Then I gave you the definition of arithmetic progression. As you know, an arithmetic progression is a sequence of numbers in which the difference between any two consecutive terms is a constant. That constant difference is called common difference and is denoted by the letter D. Then we went to the general form. The general form of an AP, as you know, is A plus D, A plus 2D, dash 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 till A plus of n minus 1 into D. Then we have discussed and derived the following formulas that you can see on the board. The first formula was the formula to find sequence of even numbers. The second one was the formula to find the sequence of odd numbers. Then I derived the formula to find the nth term of an arithmetic progression and also to find the arithmetic mean of two numbers. Now let me take the first sum for today. If En is equal to 2n minus 1, find S4 and S5. What's my question? If n is equal to 2n minus 1, find S4 and S5. Now what is S4? S4 is the sum of the first 4 terms and S5 is the sum of the first 5 terms. So first, let me start with the solution. It's given that En is equal to 2n minus 1. So first term, that is E1, is 2 into 1 minus 1. 2 1s are 2, 2 minus 1, 1. E2 is 2 into 2 minus 1. 4 minus 1, 3. What is E3? 2 into 3 minus 1, that is 6 minus 1, 5. What is E4? 2 into 4 minus 1, that is 8 minus 1, which is 7. And what is E5? 2 into 5 minus 1, 10 minus 1, 9. I asked you what is this S4, I asked you what is S5. What is S4? S4 is the sum of the first 4 terms, A1 plus A2 plus A3 plus A4. So you get 1 plus 3 plus 5 plus 7. You get a sum of 16. I also asked you to calculate the value of S5. What is S? Find A1 plus A2 plus A3 plus A4 plus A5. So you get 1 plus 3 plus 5 plus 7 plus 9, which is 25. The value of S4 is 16. The value of S5 is 25. Now let's see what is S4 minus S5 equal to. What is S5 minus S4 equal to? What is S5 minus S4 equal to? What is S5? 25. What is S4? 16. I have got a sequence of odd numbers as you can see over here. 1, 3, 5, 7, 9. S5 is the sum of all these 5 terms, which is 25. S4 is the sum of all these terms, which is 16. So what is S5 minus S4? 25 minus 16, which is equal to 9. What is 9? It's the fifth term of the sequence. So I have come to the conclusion that S5 minus S4 is equal to A5. With this, I derive a new formula. That is S5 minus S4. I know that S5 minus S4 gives you A5. A new formula, S5 minus S4 is equal to A5. I can generalize it as Sn minus S of n minus 1 is equal to An. What is Sn? Minus S of n minus 1 equal to An. This is the third formula, that is Sn minus S of n minus 1 is equal to An. If I give you another sum of the same type, if the sum of the first 5 terms, or if the sum of the first, if the sum of the first 10 terms, if the sum of the first 10 terms of a given sequence is 100 and the sum of the first 9 terms is 81, then find the 10th term. It's an objective question asked in the examination. I have given you the sum of the first 10 terms, the sum of the first 9 terms of a given sequence, and I am asking you for the 10th term. Now what's the 10th term? I use the same formula. I know that En is nothing but Sn minus S of n minus 1. So A10 is S10 minus S9. S10, the sum of the first 10 terms I said is 100. The sum of the first 9 terms I told you is 81. So what would have been the 10th term? The 10th term is 19. What would have been the 10th term? The 10th term would have been 19. Let me take another sum of the same type. Look at the arithmetic progression that is projected on the board. 2 plus 3, 5, 5 plus 3, 8, 8 plus 3, 11, 11 plus 3, 14. Let's see, what is the sum total of these terms? The sum total of these terms. 2 plus 5, 7 plus 8, 15, 15 and 11, 26, 26 and 14, 40. You can see the sum of the first 5 terms is 40. What is the sum of the first four terms? 2 plus 8, 10, 15, 15 and 11, 26. If I ask you what is A5, how will I get A5? A5 is equal to S5 minus S4. Which formula did I make use of? AN is equal to SN minus Sn minus 1. S5 is 40. S4 is 26. So your fifth term, I asked you for the fifth term. What is your fifth term? Your fifth term is 14. Sometimes they may give you the fifth term, they may give you S5, they may ask you to find out S4. The same formula. Supposing say I give you A5. The fifth term is 14. Whereas this time I am asking you what is S4. I have taken the same sequence. Here I have given you the value of S5, that is 40. I have given you the value of the fifth term, which is 14. I am asking you to find out what is S4. Same formula. So what is S5? What is A5? Is equal to S5 minus S4. What is A5? 14. What is S5? 40. This minus S4 coming to the left becomes plus S4. This plus 14 going to the right becomes minus 14. So you get S4 is equal to 26. If I had the first four terms, you get a total of 26. Okay, yes. We come back to the formula number 1 in arithmetic progression. We have used formula number 1 to find the 10th term, or if I ask to find the 20th term of the given arithmetic progression, we use En is equal to, what is En equal to? A plus of n minus 1 into d. Now, if I ask you what is d, how will I find out what is d? First step, n minus 1 into d is equal to an. Plus a going that side, minus a. What is d then? An minus a. This n minus 1 which was in the numerator going that side goes to the denominator. So another formula to find out the value of d. What is d equal to? An minus a upon n minus 1. N minus a upon n minus 1. D can also be equal to AP minus AQ upon P minus Q. Now when shall I use this formula? Supposing say I give you the third term of an arithmetic progression is 8. In an arithmetic progression, the third term is 8, the fourth, fifth, sixth, seventh term is 20, the third term is 8, the seventh term is 20. Calculate the common difference. That is the time I will be using formula number 4. What does formula number 4 states? D is equal to AP minus AQ upon P minus Q. What is D equal to? AP minus AQ upon P minus Q. So what is D? AP. You assume one of them to be AP, one of the term to be AQ. You can consider A7 AP, A3 as AQ, or vice versa. You can say let this be AP, let that be AQ. So in this case, what is AP? 20. What is AQ? The third term, that is 8. What is P? 7. What is Q? 3. So what is D? 12 upon 4. 4 ones are 4 threes are. I have got the value of D. What's the value of D? 3. Using the formula, D is equal to AP minus AQ upon P minus Q. D can also be equal to A2 minus A1. D can also be equal to A3 minus A2. You may get a question as an MCQ in exam. Which of the following is not a true statement? D is equal to n minus A upon n minus 1. D is equal to AP minus AQ upon P minus Q. D is equal to A2 minus A1 and D is equal to A3 minus A4. Which of the following is a wrong statement? D is equal to A3 minus A1 is the wrong statement. This is true. This is true. D can be A2 minus A1. D can be A3 minus A2, but it cannot be A3 minus A4. D cannot be A1 minus A2. It has to be A2 minus A1. As you know, D is nothing but a common difference which can be positive and it can also be negative. For a given arithmetic progression, 8 plus 3, 11, 11 plus 3, 14, 14 plus 3, 17. This arithmetic progression, the common difference is 3. 11 minus 8, 3. 14 minus 11, 3. If I want the next term, I have to add the common difference. What was the common difference? 3. What is 17 plus 3? 20. If I want the next term, I have to add 2 times D. Here I have D, here 2 times D. What is 2 times D? 2 into 3, 6. 17 plus 6, 23. Or 17 plus 3, 20, 20 plus 3, 23, 23 plus 3, 26. If I ask you what is the previous term, this time I have to subtract D. If I want next term, add 3 plus 3, here I will get minus 3. What is 8 minus 3? 5. What is 5 minus 3? 2. So is the concept clear? If I want the next term, add D. If I want the previous term, I have to subtract D. Then comes formula number 5. Formula number 5 states that AP is equal to AQ plus P minus Q into D. This is formula number 5. What does formula number 5 states? That AP is equal to AQ plus P minus Q into D. Let me check. What is A10? A10 is equal to A7 plus P minus Q. What is, I will write directly, 10 minus 7, 3. What is A10 equal to? A7 plus 3D. If I ask you, what is A7 equal to in terms of A4? A7 is equal to A4, P minus Q. What is 7 minus 4? 7 minus 4 is 3D. If I ask you, what is A4 equal to? A10. What should I write there? P minus Q. What is 4 minus 10? What is 4 minus 10? Minus 60. What is A4 equal to? A10 minus 60. Let's take this equation. What I said? A4 plus 3D will give you A7. Let me take the arithmetic progression. 2 plus 3, 5. 5 plus 3, 8. 8 plus 3, 11. 11 plus 3, 14. 14 plus 3, 17. 1, 2, 3, 4, 5, 6. 17 plus 3, 20. I want to check whether my statement is true. 1, 2, 3, 4, 5, 6, 7. This is A7. What is A4? 1, 2, 3, 4. Now just check. What is common difference here? 5 minus 2, 3. I said A4 plus 3D will give you A7. So A4 plus 3 in what is A4? 11. 3 into 3. 11 plus 9. What is the seventh term? 20. Is not 11 plus 9 20? Yes. This is formula number 5 for arithmetic progression. What does formula number 5 states? That AP is equal to AQ plus of P minus Q into D. If you are given a question, now this was a question asked in one of the annual examination. E of n minus 4 plus 3D is equal to dash. Second, E of n plus 1 minus 4D is equal to dash. Now when I ask you what is A4 plus 2D, at once you know that the answer is A6. A4 plus 3D, A7. A4 minus D, A3. A4 minus 2D, A2. The question asked in the exam was like this. What is A of n minus 4 plus 3D? And 4 options were given to you, A, B, C, D. Now when you get a question of this type, how are you going to solve it? This is An. The next term is An plus 1. The next term is A of n plus 2. The next term is A of n plus 3. Previous to this, what would have been? If this was A7, this would have been A6 n minus 1. This would have been A of n minus 2. Next term would have been A of n minus 3. The next term over here would have been A of n minus 4. What was my question? A of n minus 4 plus 3D. If I had D, I would have got this term. If I had 2D, I would have got this one. What is A of n minus 4 plus 3D? So what is A of n minus 4 plus 3D? A of n minus 1. This was the question asked in annual examination. How to go about with the sum? You write the middle term as An, n plus 1, An plus 2, n plus 3. Left side, An minus 1, n minus 2, n minus 3, n minus 4. If I want the next term, add D. If I want previous term, subtract D. The second question, A of n plus 1. This is A of n plus 1. Here I am asking you what is A of n plus 1 minus 4D. If I want plus D, go to the right. Minus D. Minus 2D. Minus 3D. And minus 4D. What would have been your answer? What is A of n plus 1 minus 4D? A of n minus 3. A of n minus 3. Is that clear? I have taught you so far 8 formulas. Formula number 1, 2 and 3 dealing with sequence, and 5 formulas on arithmetic progression. Now let us solve a few sums dealing with the formulas that you can see on the right hand side of the board. Take the first question. Find how many terms. My question is find how many terms. My question is find how many terms are there in the AP, how many terms are there in the arithmetic progression 3, 8, 13, right up to 253? What's my question? Find how many terms are there in the arithmetic progression 3, 8, 13 till 253. How to go about with the sum? What's given? What is given to you? That the first term is 3, right? The common difference is 8 minus 3, that is 5. The nth term is given to you. The nth term is 253. I am asking you to find out n. Once again, I am using formula number 1. Which formula am I using? Formula number 1. We know that a plus of n minus 1 into d is equal to an. We know that a plus of n minus 1 into d is equal to an. So you get 3 plus n minus 1 into d is equal to an. So you get 3, 5 into n, 5n, minus 1 into 5, minus 5 is equal to 253. So you get 5n is equal to 253. This minus 5 going that side becomes plus 5, plus 3 going that side becomes minus 3. So you get 253 plus 5, 258. 258 minus 3 is 255. So n is 255 upon 5. What is 255 upon 5? 5 ones are, 5 fives are, 5 ones are. What's my answer? N is equal to 51. What was my question? How many terms are there in the arithmetic progression? So what's my answer? There are 51 terms in the given arithmetic progression. Which formula did I make use of? Formula number 1. Let me take another sum. Today we are doing sums on only these formulas that you can see on the board. The next one is 301. My next question is 301 a term of the arithmetic progression? What's my question now? Is 301 a term of the arithmetic progression? The arithmetic progression is 5, 11, 17, 23 and so on. What's my question? Is 301 a term of the arithmetic progression? How do I start with the sum? What is A? 5. What is D? 11 minus 5. What is, let us assume the nth term to be 301. Let's assume the nth term to be 301. In that case, what would have been the value of it? Once again, I am using the same formula. We know that a plus of n minus 1 into d is equal to an. So what is a? 5 plus n minus 1 into d is equal to 301. So what will I get? 5 n into 6, 6n, minus 1 into 6, minus 6 is equal to 301. So what is 6n? Is 301 minus 6 going that side, plus 6, plus 5 going that side, minus 5. So 301 plus 6 is 307 minus 5 is 302. So you get n is equal to 302 upon 6. What will I get? N is equal to 302 upon 6. That is 2 3s are, 2 1s are, 2 5s are. So what is 151 upon 3? 151 upon 3 I think so is around 50.33333. Now, can I say that there are 50.3 terms in the arithmetic progression? No. So I will come to the conclusion that since n is not a natural number, therefore we conclude that 301 is not a term of the given arithmetic progression. What will be my answer? How will I end it up? Since n is not a natural number, since n is not a natural number, therefore we conclude that 301 is not a term of the given arithmetic progression. If n was 30, 50, yes. If n was 50, then that means 301 was the 50th term of an AP. Since n is not a natural number, we come to the conclusion that the given number 301 is not a term of the given arithmetic progression. The next one. If 4 comma x comma y comma 25 are in arithmetic progression, then find the value of x and y. What is given to you is that 4 comma x comma y comma 25 are in AP. Now since you know that this is an arithmetic progression, therefore the difference between any two consecutive terms is a constant. Here I am going to use, I know the next term I get by adding d. 4 plus 2d will give you y, and 4 plus 3d will give you 25. Am I right? If I want next term d, after that 2d, after that 3d. So my first equation, I know that 4 plus 3d is equal to 25. I know that 4 plus 3d is 25. So what is 3d? 3d is equal to 25 minus 4. So 3d is equal to 21. So what is d? 21 upon 3. 3 ones are, 3 sevens are. I have come to the conclusion that the common difference is 7. Once you know d is 7, how will I get x? How will I get this? 4 plus d, you know, is x. And x, d just now you found out is 7. So 4 plus 7 is 11. I have come to the conclusion that the value of x is 11. I want to know the value of y. I know that 11 plus d will give you y. Or I can say I know that 4 plus 2d is equal to y. I can either use this equation, 11 plus d will give you y, or 4 plus 2d will give you y. Let me use 11 plus d is y. So what is d? as you know is 7. What is B? 7. So what is the value of y? Y is equal to 11 plus 7, that is 18. Is that clear? Let me take another sum of the same type. Fill in the blanks. Fill in the blanks given that the following terms are in arithmetic progression. Dash, comma 13, comma dash, comma 3 are in AP. Once again, I am asking you to find out these two. Let's assume this as x and let's assume this as y. Let me first find out x. This time let me use arithmetic progression formula. Whenever three terms are in arithmetic progression, the middle term acts as the arithmetic mean between the side two terms. So what is A? Small a plus small b upon 2. E, I assumed it as x. So x is 13 plus 3 upon 2. So x is equal to 16 upon 2. So what is the value of x? X is equal to 8. So I got this number. This number, as you know, is 8. Now once you know that this is 8, tell me what is the common difference. Common difference is difference between any two consecutive terms. What is 3 minus 8? Minus 5. What is the common difference? Minus 5. That means if I want to know the next number, what should be added? Minus 5. But if I want to know the previous number, not minus 5, plus 5. So what is 13 plus 5? 18. So y is equal to 18. I got the value of x, I got the value of y. This was a fill in the blank question. Find the value of x and also find the value of y. Next, let me take the third term. The next question. The third term of an AP is 16. The third term of an AP is 16 and the seventh term, what I said, and the seventh term is 12 more than the fifth term. Find the arithmetic progression. What's my question? Find the arithmetic progression. What is given to you in the sum? I said the third term of an arithmetic progression is 16. Just have a look at the arithmetic progression. I have written an arithmetic progression on the board. Can you see? 4 plus 6, 10. 10 plus 6, 16 plus 6, 22 plus 6, 28 plus 6, 34 plus 6, 40. What did I give you? The third term is 16. Third term is 16. What was my second relation? The seventh term, which is that seventh term, 40, is 12 more than the fifth term. Correct? Is the seventh term 12 more than the fifth term? Yes. A5 plus 12 is A7. What is A5? What is 28 plus 12? 40. I formed a sum by writing one arithmetic progression. I told you that the third term is 16 and I gave the relationship between the seventh and the fifth term. And I am asking you to find the arithmetic progression. Now, how am I going to do this sum? What is given to you in the first step? is that the third term is 16. Solution set. I know that the third term is 16. That means the value of a plus 2d is 16. Right? Then one more relation. The seventh term, what did I say? The seventh term is 12 more than the fifth term. What was my second relation? The seventh term was 12 more than the fifth term. So what am I going to get? What is A7? A plus 6D. What is A5? A plus 4D plus 12. This plus A and this plus A cancels. So you get 6D plus 4D coming this side minus 4D is equal to 12. So you get 6D minus 4D is 2D is 12. What is D? 12 upon 2. What is 12 upon 2? 6. I first got the common difference. What was the common difference? 6. What did I ask you? To find the arithmetic progression. If you want to know the arithmetic progression, I should also know the value of A. Now how to get the value of A? There was one condition. Condition number 1 said that the value of A plus 2D is 16. I told you the third term is 16. So A plus 2 into 6 is equal to 16. So you get A plus 12 is equal to 16. So what is A? 16 minus 12. So A is equal to 4. So now I know the value of A. I also know the value of D. So let me write the arithmetic progression. So therefore the arithmetic progression is A plus D, A plus 2D and so on. So what is A? 4, 4 plus 6, 4 plus 2 into 6 and so on. So you get 4, 10, 6 to the 12 plus 4, 16, 22, 28, 34 and so on. I found my own question by taking an arithmetic progression. I gave you saying the third term is 16 and I also told you that the seventh term was 12 more than the fifth term. Find the arithmetic progression. Okay, so with this let me stop my second session on the chapter arithmetic progression. We'll continue forward in my third session. See you. Goodbye. Take care. Take good care of your health. Thank you.